All right, here we're looking at our notes for section 6.6, and here we're really going to be solving, you can see this learning target right here, solving exponential and logarithmic equations and inequalities. So the first thing I want to remind us of is back on this sheet, back in 6.3, we learned what a log is. So the question asks us, this answer over here is, what exponent do I need to get from this base to this a, right? So how do I get from here to here? What exponent is that? So if these two things are the same, so if I have log base 3 of 3, well, 3 to the 1 is 3. So those two things would kind of cancel each other out and turn it into a 1. Okay? So that's kind of undoing itself in reality. Okay? So this will come into play when we're solving it. So now we're going to go to our 6.6 notes, and we're going to need, we have both a green one and a yellow one. The green one is our equations, so we're really going to start there. So let's start looking at the property of equality for our exponential functions. Okay, so our property of equality tells us that if b is a positive real number other than 1, then b to the x equals b to the y if and only if x equals y. Okay, so this can work backwards too, so that if I know that my bases are the same, my exponents then have to be the same as well. That's really what we're trying to see here. That if I can get my base to be the same, I can get my then my exponents are then the same. Okay, so let's go ahead and work on solving this one together. So the first step is I see that both of these can be written with a base of 10. Okay, so that's going to be our important part, is where let's start with writing this with a base of 10. So here I know 100 is 10 squared, so I've got, oh, my pen's not working. There we go. 10 squared to the x equals, and here remember we have negative exponents, and what those negative exponents do is switch the side of the fraction. So I need this to be back in the numerator, so it's going to be to the negative 1, so 10 to the negative 1, and then I have my x minus 3. So from there, right, so now I have them both in base 10, I can use my power of a power property to actually get this kind of simplified. So now I have 10 to the 2x equals 10 to the negative x plus 3. I just distributed my exponents, and I can do that because it's a power of a power. Well, now that my bases are the same, I just set both of my exponents equal, so 2x equals negative x plus 3, and then I can solve for my x. So I'm going to add an x to both sides, so I end up with 3x equals 3, and so I divide by 3, so x equals 1. So our goal was to get our bases to be the same so that we can then set our exponents the same and solve for there. So what if we have something like this where I can't really rewrite these with the same base? Here's where we're going to use what we know about logarithms. So remember when math, what I do to one side, I have to do to the other side. So here we're going to go ahead and take both of these, take the log of both sides. And so here, since I want to kind of get rid of some stuff and make a 1, I'm going to use my base 2 because that's going to really help me figure out this exponent. So if I take log base 2 of both sides, okay, I see that here I have this exponent that following my properties of logarithms that we just learned in our last section, I can pull that out front. So I have x times log base 2 of 2 equals log base 2 of 7. Well, here we just discussed that if I have a log base of something to itself, this, since these two numbers are the same, equals 1. So now I have x equals log base 2 of 7. Here, since I just have an x and this is where I would use my calculator. But when I'm using my calculator, I have to be very careful. If I'm using just a normal calculators don't have a base 2 button, so I would have to use my change of base. And remember that to use the change of base here, I would do log of 7 divided by log of 2, because the 7 is written a little bit higher than the 2, so it goes on the top. So if you're using your calculator, now I see I can get this into base 10 and actually put that in my calculator. So these are the steps you're going to kind of be taking. Okay, so that was our property of equality for exponential. So now what about the property of equality for logarithmic functions? Okay, so if b, x, and y are positive real numbers, that b is not 1, right? Our base is not 1. Then my log base b of x equals log base b of y if and only if x equals y. So again, I have to get myself to having the same base, and then I can set everything else equal. So let's go ahead and look at what these examples look like. So just like we did in the above examples, that to solve for an exponential, we could take the log of both sides. Well, here I have the log of one side, but not the other one. So what if we kind of undo that by taking both sides and making them both exponents? So now I'm going to have 2 to the log base 2 of 5x minus 17 equals 2 to the third. And the reason I'm using 2 here is because that's the base that I had, and that's what's kind of going to make them all go away. So 2 to the log base 2 kind of goes away. So now on this side I'm left with 5x minus 17 equals, well, I know what 2 cubed is. 2 times 2 is 4 times another 2 is 8. So then I can solve for my x. So I'm going to add 17 to both sides. So I end up with 5x equals 25. Divide by 5. So x in this case would equal 5. So just like using all of my other inverse operations, I can do that as well. Well, so now what if I've got multiple things like this? Oh, well, here is where we can go ahead and use those properties of logs, since I see I'm adding them, to go ahead and combine them and condense them. And I remember back from those that when I was adding, that can turn into a log, and here we look at base 10, because nothing is there, and I multiply, equals 2. Well, so now how do I undo this and get rid of it? Since this is base 10, we're going to use our base of 10. So I have 10 to the log equals 10 squared. So now to simplify that, I end up with 2x times x minus 5 equals 100. Well, so now let's go ahead and just simplify this and distribute my 2x. So I end up with 2x squared minus 10x equals 100. Well, I'm going to go ahead and simplify it just a little bit and divide everything by 2. So I end up with x squared minus 5x equals 50. Okay, because I divided this by 2, and I divided this by 2, and I divided this by 2. So now is where we can go ahead and solve for our x values. And remember that now we're dealing with a quadratic, so there's different ways around how we can do that. So always our first way is to try and factor it. So let's get everything over to one side, equals 0, and see if there's any way we can factor this. Well, I know 1 times 50 is not going to get me 5. 2 times 25 is not also. What about 5 and 10? If I have x minus 10 and x plus 5, that's how I can factor this out. So then I can solve each of these using my zero product property. So x equals 10 or x equals 5. And go from there. So all I've done was I took this, and since I had a quadratic, I tried to factor it first. If it wouldn't have been factorable, then I could use the quadratic formula to solve it. But this one ended up being factorable. So now I'm going to take both of my solutions and plug them back in to try and just make sure if they both work. And if you plug these back in, oh, this is a negative 5. You'll see that this negative 5 ends up not working, because I would end up right here with a log of negative 10. And we said here that all of these have to be positive real numbers. So here I would end up with a negative number. So that tells me that this solution is extraneous and doesn't work. So I really only have one solution here. Okay, so there's solving some of those equations by using some inverse properties. So now let's look at what we have when we're solving some inequalities. So solving these inequalities is something very similar to what we just did. So let's look at that exponential inequality. Okay.